Hello and good afternoon. I'm Dave Torok. I'm joined here by my colleague Imran Amjad, and thank you for letting us share our journey to self-service architecture and data ingest. Just a program note, immediately following this session, we have a companion session called Self-Service Lunch Ingest with Chicken and Salad. All right, so we're from Comcast, and some of you may have Comcast as your home internet provider, your cable TV. Perhaps you visited one of the many theme parks we have or seen one of the Universal movies with or without the Minions. And there's also a venture capital arm, Comcast Ventures, which is right up the road in Palo Alto. So just some background and some context about our team. We're in the customer experience area, and we have a UI which is surprisingly used by 30,000 unique internal users per month, and that's about 1 in 5 Comcast employees, so it's pretty widely used. We're on the smaller side of data ingest. We do about 2 billion events per month. That's about 60 million a day. Not quite at the scales that some of which I've heard about elsewhere in the program, but not small either. And we also have about 14 million requests per day from a variety of different channels, including when, for example, you would log on to your My Account app. It will read some data from our application. So we grew in the past year from about a couple dozen data feeds, different events, and we've added somewhere between 5 and 10 events per 2-week sprint, and we're now at over 150 data sources and maybe close to 200 different kinds of events. And we focus, since we're in the customer experience area, on high-touch, high business value interaction events like a truck roll, an appointment, maybe picking up a self-install kit from a store and actually activating it. So we want to welcome all these kinds of interaction events from different data providers, and we've had quite a pipeline, as you can see. So I'll give you the boxes and lines, high-level architecture. It's actually a very typical pipeline, as you might see. Let me put the overlay here. We have data ingestion. We have a storage layer with a event store, operational data store, as well as an analytics database, and a serving layer with our API and our UI. There are a whole lot of pieces that I'm not going to show and talk about, such as our security and privacy controls and other kinds of operational architectures. But one of the things that we do is no matter where the data is coming from, batch, real-time, different protocols, we do put it all into Kafka so that we have a single source for our streaming ingestion into the data store and for our analytics and active decisioning pipeline. All right, so why did we want to make the move to a self-service architecture? And there were 3 main motivators. The first was time to market. Our VP said many times, I would like to be able to add a new event stream in about 10 minutes, which is a nice goal to shoot for, so that's what we're doing right now. We had a lot of manual processes, and we had a lot of code to deploy previously. And as you know, data ingest is pretty hard. It's a large space. Yet we have 4 dimensions of variability here that can come in on different kinds of transport, Kafka, HTTP. We have to grab files. It could be real-time or batch. The formats vary. There's a lot of JSON, a lot of custom and CSV and other delimited. And for architecture, sometimes data providers can push to us, and sometimes we have to go and pull from the source. So this was our previous process for data source onboarding. Now, I said that we did about 5 and 10 data sources per 2-week sprint. But really, the lag time from when a data source was identified to when we had it in production could be as long as 2 months. And the reason why is that we had multiple teams, lots of manual processes, and lots of coding to do across the different tiers and pieces of the architecture. So we came up with 5 self-service architecture principles that we're holding to in our new architecture. First is we want to be metadata driven. We want to have the metadata drive all the components across the pipelines. We want to automate so that no matter what happens when a new data source is identified and put in here, that all the components are done without manual processes. We want to have rapid onboarding through a self-service portal. We want light data governance, and I'll explain what that means a little bit later, so that we do have a schema-backed registry and schema-backed data. And lastly, we want to monitor and have metrics about everything. The ingest pipelines, their health, the health of all the components in the system, and have dashboards so that we can see what's going on at any given time. Right, so let's put self-service on our architecture. In the lower right-hand corner, you'll see we've added the portal an API, and most importantly, our self-service metadata content and management database. And that is the heart of our solution, because that will drive the operation of all the components across the pipeline. So let's dig deeper into metadata and data governance. It's an important topic. So if the heart of our solution is the metadata management, the heart of that is our data model, the schemas, and our registry, and what all our events look like. And with that, we can drive our ingest metadata, our processing, our UI and rendering, and other business content, enrichment, notifications, things like that. So there are different categories. So as an example of a tag, and you might recognize this kind of talk if you've gone to any of the Atlas type talks. So in UI rendering, you might say this particular event renders with this color and this icon. For security, you might say the particular piece of data is sensitive and it needs to be encrypted. And here is a reference to the key that you would pull from a key management store in order to encrypt it. We also have information about the data source, what it's called, where it's coming from, who are the data owners. And when you dig down into the individual fields, information about the field. What is its type, where can it be found, and where do we want to put it? So why data governance? There are three motivating factors, and you've probably heard some of these before, but we really want to have good data quality. In our solution, we want to validate for required fields, as well as structure and adherence to the schema. Data rationalization is about more the semantics. Can we take two different events and correlate them and join them on a common key? Can we put some of the data that's coming from different events into some standard domain objects so that we can see similar information across multiple kinds of events? And lastly, data curation, which is the sort of the overarching, what are all my sources of data? What do they look like? What are all my schemas? And importantly for us, who are the data owners? Can we contact a team if there's a problem with a particular data source ingest? Right, so what's our approach to lightweight data governance? And there's a few parts. Our first question was, which schema language are we going to use? Now, we love Avro. We've used Avro for the past year plus. Other groups in Comcast are using Avro. But we had some problems and we had some particular needs in our use cases where Avro wasn't quite the ideal solution. For one, many of our data sources and providers are not using Avro. So as you can tell, across the organization, people might have CSV, JSON. It's a little bit of a bother to ask them to produce Avro for us. Secondly, we don't store Avro in our data storage. Our UI layer doesn't use it. So it also seemed to make not quite sense to convert it from something into Avro, validate it, then unconvert it into whatever we're storing in our data store. But what's really driving our use case here is that we want to be accepting of data. We want, if the schema changes, if someone adds another field onto their payload, we don't really want to break. We want to detect that. We want to accept it. We'll store it. But more importantly, we'll notify the data provider and let them know, hey, you've changed something. Please come into our portal, change your schema, and then you'll be able to see it on our UI. Lastly, we are looking at AWS, and a lot of the tools in AWS are JSON-friendly, but not necessarily Avro-friendly. It's a mixed bag, and it depends on what you're trying to do. So what are we doing with our lightweight data governance? We are going to have version data and version schema. So like with Avro, we can do that with JSON schema. We're going to detect with data quality. We're going to validate. We're going to send messages if things aren't quite perfect. If things can't be parsed at all, we will store those off and send all sorts of red alerts back to the source. And we will have that data change tolerance. That's my favorite part. We will detect those unknown fields. We'll shunt them off into an unknown data section and give the feedback back to our data provider. And then having this data quality loop will ensure that the data producers are responsible for their data quality. And just a little bit more about the how we're doing this. So we have a lightweight metadata repository today. It is an in-house repository that we're just having on MySQL. We are considering Atlas and the Hortonworks schema registry, but at least for this moment in time, Atlas is a little bit heavyweight for our team's use. We will have about 5 to 15 core defined schemas for things like customer, device, geolocation. And the first bullet is a little bit funny. It says reduced schema review and approval process. We're actually dialing the needle down to 0. We're going to have no human review and approval process, we probably will have to gate that back up. But for the moment, we wanted to see how it works with lots of data producers doing their own ingest, doing their own mapping. So we'll see how it goes. I'll turn this over to Imran to show you the onboarding portal.
Thank you, Dave. Hello, everybody. This is Imran. I think the mic is not turned on. It's not on. Can you hear me? Can you hear me now? Oh, great. Thank you, Dave. Hello, everybody. This is Imran Amjad. I also work for Comcast, and I hope you guys are having a good time so far. Let's take a look how we have transformed this data onboarding process for Comcast. But before we go in the details, I just want to highlight some of the challenges that really motivated us to build this new self-service data ingest platform. And for the first challenge, as Dave mentioned, we were manually creating Avro schemas, and there was a manual step for review and approval process. The second biggest challenge for us was that we were manually creating the artifacts like Kafka topic, like Avro, like the Nifi flow, and then we were manually changing the APIs and the UIs to visualize the new data sets as we were onboarding them. And the third biggest challenge was that when we scaled out this platform to hundreds of different data sources, it was really hard for us to keep up with the issues and really identify like who is responsible for the data issues. So there wasn't really a nice way. So we were manually keeping track of like, in the wikis that, okay, this data source belongs to this producer and team. So all these challenges we try to solve with this new GUI that I'm going to show you. We made that process in 5 steps. So we let the producers define, bring their data to our platform, also define what it should look like, what should be the source schema, what should be the target schema, and also give us some metadata about the data. And that metadata actually help us do a lot of automations that we didn't have earlier. So I'm going to deep dive into each step here. The first step is really you tell us what your name, what's your contact, or what your team contact looks like. And then the next step is basically you start defining your event, you describe it, you let us know if it's a real time or a batch, because we're going to have a different treatment based on the nature of the data. And in the third step, we let the producer upload their samples. It could be like a JSON document or a flat file. This is really helping us understanding what the source schema looks like. Now from there, we can start helping producers define what the target schema looks like. And so in the next screen, you'll see this is where the user uploaded a JSON file, and then user will have ability to select which fields producer wants to retain in the target schema. Also mentioning that, okay, this is the timestamp when the event occurred, and this is the key for the customer so that we can pull this data by the customer ID. In the next screen, producers actually work on defining each and every field and also tagging the field so that we know when a certain field is sensitive that needs to be encrypted, or there has to be a special treatment we have to apply on that field. In the final step, we let the user set the display preference. So this is part of the metadata that really help us visualize how the event should be rendered on the UI, location where the event should be rendered, as well as the icon and the color. So at this point, user has performed all these 5 steps, and user is ready to store that schema and the metadata in the metadata store. Once the user do that, we provide a link where it's a push button. So if you click on the register link, all the artifacts related to that metadata or the event is going to be created automatically. So here is our flow. So for that purpose, when user clicks a registration button, there is an orchestrator API that looks at the metadata and then go create all the Kafka topic as well as the Nifi flow. Most of the cases, your Nifi flow is going to do same thing like listening to the Kafka topic, doing XYZ with the data, and then going to store it in the database. One of the artifacts here is the Jolt as well, which Dave is going to talk about in more details. But this is actually, the idea is that we know the source schema, and we need to transform it into a target schema. So Jolt spec is created automatically, knowing both the schemas, and this really helps us transform on the fly. The other artifacts, like if your data source is batch, we will go create directories. We'll give adequate permissions to the producer so that they can only upload files to certain directories. And as well as if your data has some sensitive fields that needs to be encrypted, we create encryption keys necessary to make sure that the data is encrypted on the way in before it gets stored in the data store. So now you've seen that our whole onboarding process has become linear and it's more predictable. It's now in the hands of the producer to how quickly they can start integrating and ingesting live data into the platform. So the fourth step is basically user is creating the schema, registering all the artifacts, and then and the third step is basically testing it before that event is made published and is visible to all the users. Now Dave is going to talk about the Nifi flows.
Okay, so basically we're going to drill down a little bit into how we do the transformation from the self-service ingest and how we dynamically generate Nifi flows. So we know we have a target schema, we have a source schema, we know about the fields from our metadata repository. How can we link that all up? A simplistic way, and sort of the first way we would look at, is using something like JSON path to find the data. So if you're not familiar with JSON path, on the right side you can see there are some path names, $.id. It points to that particular value from our JSON payload. You can dig down a couple more layers, category name equals dogs, and there's also some more complex syntax to find different array values and even do some conditional search. So let's take a Comcast payload here. So we have a source that someone's onboarding, and we see that there's this evt.ets, looks like a timestamp maybe in UTC format. There's an account.bill_ID, that's probably a customer's ID, and then we'll take the location UTC off that tells someone the UTC offset, not quite a time zone because it switches with daylight savings, but we'll give them a pass for now, right? And here's a target schema payload that we generate, or rather, this is the target payload that we would expect given the schema that we have. So there's a schema identifier, but more importantly, we have the billing ID not only as a top-level correlation key, it's also in the domain object of customer account. We have our timestamp field, and our UTC offset is an a time information payload. Whoops, sorry. So you can say, here we've got JSON on the left, we've got JSON on the right. For every from field in our incoming payload, this is where we're going to put it. Sometimes it's more than one, sometimes it might be an array, but you get the idea. If only it were that simple. As you know, when you start getting data sources from who knows where, there are so many variations, so many edge cases. This might cover 80% of the sources, or maybe cover 80% of the information in any given data source. So that's where Jolt comes in. Jolt is a library, it's open source, Apache 2 licensed, and I can't say enough good things about it. We've been using it for more than a year. It has a rich DSL, domain-specific language, for doing JSON transformation. You can insert defaults, you can switch things around, there are even some light expressions. And in recent releases, Apache Nifi does have a Jolt transform JSON processor built in. And like I said, it's a great tool. If you're doing anything with JSON, owe it to yourself to look at it. Now, in the context of Nifi, you can open up the processor and put your Jolt specification. It's a declarative way of saying, this is how I want my transformation to occur. And in this example, you put the specification on the top part. On the left side, you can paste a sample JSON input and press transform and get the expected output on the right side. Once you're happy that the transformation is doing what you want, you can press save and it is saved off. Now in our application, in our pipeline, we're going to generate the Jolt spec in most of the cases. Now when you get to those advanced cases, we'll let the user perhaps edit the Jolt specification themselves to do those tweaks and edge cases. So I'm going to go into just a couple of the more exotic things that Jolt can do, just sort of the next level. You're going to have to avert your eyes if you're allergic to code or really, really badly written things, but it works. So let's take an input. Someone has miraculously put an array in JSON, and the output they want, for one reason or another, is to unroll that array into _0, _1 to flatten it out. And they also want to concatenate the different fields there into a single changed reason string. So the spec that will do that is in the middle. Like I said, your eyes will burn, don't look too closely, but it works. It'll take that input and it'll transform it to the output, and it's very nice, and once you spend a few days working with Jolt, it becomes second nature. And just one more similar example, here are a couple of IDs and model IDs that are different layers and different depths of the JSON, and we can very easily write the Jolt spec to put them into a single flat array with slightly nicer field names. All right, so once we know how to generate our Jolt transformation, now it's time to generate our Nifi flow. Nifi has a REST API. Anything you can do in the UI, you can do with a REST API, so it is pretty simple to create a full flow. So the first thing we're going to do is create a process group. It's a container for the flow underneath, and it is as simple as doing a post to this URL, and the payload, the one piece of data that we're going to take from our metadata repository is just the name of the event type, in this case, x1 info. And boom, I do that post, and I've got myself a process flow, process group. The next thing we'll do is create a consume Kafka processor. So here it's very similar. There's a there's a URL you go to create a processor. You give it an ID, which is actually the ID from, I believe, the process group. You give it, now from this example, we're using two pieces of information from the metadata. The first one is a generated topic name on Kafka. So as Imran mentioned, a Kafka topic has already been generated by the register button. Now we're going to refer to it in our Nifi flow, and we'll also name the processor with x1 info as well. And with a little bit of hand waving, we now have a complete flow with the other pieces that we need and connect them. So we have a consume Kafka processor, a Jolt transformation. The third one is actually generating a database unique ID, and the fourth one is inserting the payload into the ID. We also have, in this particular example, two error fallouts. The first one is if for some reason we can't parse that JSON, we're going to push it onto a particular error queue in Kafka for later consumption and for review by the data producers. If that put Kafka fails for some reason, we have a failsafe of logging attribute to disk, which we hope to never have to do, but if for some reason Kafka were down, that could be, and it doesn't back up properly here, then that will happen. What I'm not showing are some of the other things that we have for reporting back to the data producer. All right, I'll turn this back over to Imran.
Thank you, Dave. This is awesome. So let's talk about some of the operational metrics and anomaly detections in the data feed. I think this is something that's every day you have to deal with. And how that means to the self-service data ingest platform, right? You're automating all the artifacts, but then in the operations, what happens? What is the impact on the DevOps model? This is one of our Tableau's data, dashboard that really tell us that what is the ingestion status per day for all the feeds. So vertically, you can see all the events, and then horizontally, those green and red sticks tells you that on a certain day we got data for this. But then if you further click on each and every stick, you will see how many messages you got, you ingested successfully, how many were the bad messages or invalid messages and didn't have the proper schema. Here we see you guys are seeing two data centers here. For our operational purposes, we basically have an active-active, so we send data on both data centers. The next slide is basically we're using Anadot to detect anomalies in the feed. So for example, if the issue is at the source level and the source is somehow due to maintenance or some issues, stop sending the data. Or issue, for example, on your side where your Nifi flow or your component has stopped working for some reason, you can, Anadot can immediately detect in real time an anomaly that, okay, in the last 5 minutes, the rate of ingestion has slowed down from 200, let's say, requests per second to, let's say, 5 requests per second. So it can send alerts to you, but also it gives you ability so that we can deep link that dashboard to the producer and make that a producer problem if the issue is on the producer side. Because as a platform owner, you really want to segregate and make sure that you spend your time working on your platform reliability, stability, and not solving somebody else's problem. So from self-service perspective, what it means that you're creating your dashboards automatically as well as you onboard new data sets. This is our last slide. We just want to share some of the lessons learned so far. The first thing that I want to mention is that always design with the automation configuration in your mind. This is really true from DevOps perspective, and how the power of the orchestrator API that you have seen, it really helps you on the fly create all the artifacts that you need, starting from the Kafka topic, any authorization keys that you need, Nifi flow. Most of the time you will have templates to create the Nifi flow, because 80% of the times your flows will be really standard. Also, from operations point of view, I just mentioned that you want to update your dashboard, and some of the tools are out there. For example, Grafana, that gives you an API. You can call the API as soon as you see that there is a new feed or new Kafka topic there, and the new feed has started coming. You can update the dashboard to reflect that, so the DevOps team don't have to manually go and update the metrics. The second principle here is the metadata-driven design. This is so powerful, and that has really helped us, build this platform. What that really means that, for example, in our APIs and UIs, we were manually changing those the code and to reflect the new changes. That can be, we don't have to do custom development anymore. With the metadata and data-driven APIs, we can now paint the picture as soon as a new data set is onboarded. We know how to display that. So we solved that challenge as well. The third lessons we learned was that make simple things simple. For example, if you have a complex scenarios where you have use cases beyond 80% of the easy use cases, you don't want to create very complex UI experience for the producer. You might just want to give them an interface where they can simply run SQL queries, or they can define a complex Jolt spec, so that you don't become like a bottleneck for the business. The fourth lesson we have is the segregation of concerns. So if, for example, if the issue is at the data producer side, you just want to notify, make them accountable, but not just make them accountable, but also make their life easy. Alert them when there is an issue, and also provide them a deep link so that they can see what bad data their system is generating, so they can go and fix it. And last but not the least, Nifi and Jolt is a really powerful tool. We've seen a great value, and this is how we are basically achieving self-service, transforming from the source schema to the target schema, because we have about 150 different data sources, and it's really hard. Every source is different, so you cannot change the source, but what you can do, you can change how you store the data in your system. So we highly recommend Nifi and Jolt together. With that, I want to thank all of you coming here, and we are open to questions. But before that, I just want to mention one more thing. We are also hiring at Comcast, so if you guys are interested, please come talk to us. Thank you.
Thank you.
Sure.
How are you guys handling external data feeds, like someone's SFTPing a file up to you? How does that feed into your Nifi flows? Are you?
So if I hear the question, it's how are we handling files?
Coming in as not coming in.
Feeds that are coming as files. So we do have in the automation, we create a directory where the files can be put. From there, we have a notification where we go and actually extract it and feed it through into Kafka. So we have basically a file detection, kind of like,
You're not worrying about after, you don't care until it lands on the file system. You don't look what happened before.
So we kind of have two models. So the push model is that someone can put a file in a directory, or they can post to HTTP, which we have a gateway into Kafka. The other model is pull. So in our current solution, we sometimes have to pull from Rabbit, from JMS, from someone else's FTP. For that, we're using Nifi in some areas, in some areas, some other scripts. But either way, we're going to push it into Kafka as our single ingest choke point, if you will. Hmm? Yes?
What's the motivation for someone to add their data?
So it's a good question. What's the motivation for someone to add their data? So like I said, this is being used right now by about 30,000 internal users at Comcast. A lot of teams want their data to show up in that UI, especially in the customer care. Someone say, oh, I've got this interesting data set of when someone activated their their box after they received it in the mail. They want to see that. They're going to, previously they'd asked us to onboard their data. Now they will go through self-service and add it themselves. It remains to be seen whether we have to put in some kind of filter on someone adding data that has, it's either too noisy or doesn't have a lot of value for people. But at this point, we have people lining up at the door to give us their data. Yes? How do you connect the ingestion dashboard back to Nifi flows? So a little bit of hand waving there. We've tried to do a few of the metrics back to Ambari with some minimal success. We're probably going to use in the newest version of Nifi the scripting recording metrics to get it right to Grafana and other things like that. But back to Nifi flow, I'm not sure what you meant by doing it in the Nifi flow.
It seems like from the UI that the Nifi flows were visualized like a green and red status.
Oh, that was not a green and red status. So it was actually, I'm sorry, you said that the Nifi looked like green and red status. Actually, it was actually just my color coding for a source and a sink that I've been using throughout the past year or two. Yeah, no, we were actually, from a notification to the data producer, we'll probably have both an accessible dashboard as well as alerts that actually get emailed or slacked to the right people and teams. Question, yes?
Are you handling very large file shipping or ingest through Kafka? Because I know Kafka becomes built performant after 1 megabyte payload.
Right, so the question is, are we using huge files through Kafka? So we're actually breaking up the files before they get to Kafka. So once they land in a bucket or a directory, we have a process that will read it, chunk it, and actually break it up into the individual events as they go through Kafka. So we're shredding it in advance. Yes?
Just a generic question. Do you guys see yourself continuing with the Kafka stream, or with so much Nifi, can you guys see the provenance of doing a Nifi to Nifi later on?
Question is, are we going to continue using Kafka or do the provenance from Nifi to Nifi? I don't see like a messaging bus going away. We use it as an event bus in our active decisioning pipeline as well as our ingest. And we're not quite as interested so far in that provenance from Nifi as far as like internal lineage. I know some organizations like the lineage we're going to see all the places it's gone through. We're primarily interested in lineage from where is it coming from, where is it in our platform, and not so much of going from 25 different other places in between. Okay. Right. Sure. Somebody. Can you repeat that? It was how do you How do you define whether data is anomaly or not? So do you mean the data or do you mean the rate of ingest? Because the data itself, we're using JSON schema validation to validate that the payload is conformant to its defined schema. I mean, clearly there are things that you might not validate there as far as whether semantically it makes sense. From a ingest pipeline, we're using Anodot, which is anomaly detection, so it establishes some baseline rate, and when it falls above or below that, it detects that. Do you want to say anything more about that? Or?
No, I think that pretty much covers the. We only detecting anomalies at the data feed level. Within the data, for example, we get orders data, and there could be like hundreds of different items in the order, and suddenly, let's say one of the item we're not getting any data as well. So we don't have a nice solution right now. But eventually, we are thinking that we can probably use Anodot or maybe develop something custom that can detect that, okay, now we're not getting, let's say, voice orders going forward. So this is something on our minds, and we're working towards a solution.
Yes.
How are you guys handling security and self-service? Is it security
Yeah, so as I mentioned in the beginning, I wasn't going to get into the security architecture too much. We do have at each layer security and privacy keys. We have authorizations for ingest on a per HTTP path level. So a given team will get authorized to put in only certain streams. From the UI perspective, there are all sorts of role-based controls and things. So it's pretty pervasive in Comcast as well as in our platform. Yes. Oh, you're gonna have to speak up. Sorry. So, Right, so for today, now our architecture is evolving a little bit. For today, we're storing our operational data store. We have two versions. We have an H-based version, and we have a key value store in a large cloud provider. And internal to that, it's JSON payloads or whatever they're storing internally. We also have several analytics databases in different formats. So like today, we do some extracts to Hive, and we do. We're looking at some things with yet another, the cloud provider's analytic database, and so there's going to be different formats. But we're primarily thinking that, we'll work with JSON. We're not huge data. I mean, it is growing every day, but still, 60,000 events per day isn't, the billions that you see at Netflix, Yahoo, or some of the other talks that you've seen. Yes. I'm sorry? Is this tool available for general public to try out? This tool is an internal tool. I mean, when you say tool, this is an entire platform, unless you're talking about the portal itself.
Yeah, I'm talking about only the automating the task.
All right. So can never say never, because Comcast does contribute to a bunch of open source projects, and there are other Comcast authored things. So I'd say, let's see where we are in a couple of years, and who knows, maybe we'll talk again about it, but I can't say one way or another. I don't know how much time, sure.
How long did it take you guys to build that framework, and how many people were involved in building that platform?
The platform as a whole, or the UI?
Ingestion, UI, and the practice to generate the code in Nifi, generation of the topics.
Yeah,
It's
so,
the automation hub.
yeah, I mean, it's hard to put a number on it. I mean, our team has grown. I mean, we're now somewhere in the 40 to 50 range in total, but it's covering lots of things. We have a small UI team. We have people who are experts at analytics, and so it's a team effort. We have just lots of stuff going on.
The product, was it 6, 12, 18 months?
It's 6 months.
So far, I think we spent last 6 months in building our first prototype that, we started leveraging it for the simple use cases for Comcast. So basically, dog feeding, our solution to Comcast for Comcast being our first customer.
Right, but we're taking a learning. So we've been on production on Nifi for over a year now, handling millions of events per day. So we're taking the next level of, okay, we know how to do it in Nifi when we have to do it kind of by templates and modifying, and now we're going to do it by generation from metadata. So we're building on the concepts that we learned over the past 3 years. Yeah. Okay. One
Please.
last question, please. Yeah.
Out of curiosity, did you consider pre-existing tools to do report, like Kylo or something?
So we had looked at Kylo previously. Kylo is a way of doing a templated Nifi deployment where you have certain fields you can fill in, and then it'll generate the template and deploy it to Nifi. But we really wanted our metadata and our data-driven solution to cover all of the components in the entire pipeline. So while Nifi we use primarily as the ingest, we have a lot of other things, as you saw. We have UI, we have services, we have analytics. We're moving into active decisioning, where people hopefully will be able to author some of their own analytics, maybe in a SAM-like way, and maybe using SAM, who knows, but that's an area that we're looking at very strongly. All right, thank you very much.
Thank you.